curious-minded friends, I'm Dr. Becky and welcome to this, the very first Sky News for October 2018. So in this monthly series, I'm going to be going over everything exciting to see in the sky in this coming month, and then also discussing last month's news in all things space and astronomy. Before we start though, I just want to say a quick thank you to everybody who's subscribed in the past couple of weeks since launching. It's great to see everyone engaging in the comments, and yes, mics and lights are on their way, I promise.
I know, my camera's not in focus. Brady usually sorts this stuff out. Bear with, it focuses after about 3 minutes.
Right, so let's kick things off and start by looking up. So something nice and easy to start with. Tonight, Wednesday the 17th of October, the moon will be on one side of Mars, and then by tomorrow night, on the 18th of October, the moon will be on the other side of Mars. So if you look to the south tonight, you will see a half moon and then also Mars next to it. Mars will look like a star, but it will be very red and very, very bright, which is how you can pick it out. And then tomorrow night, if you look around about the same time, the moon will be on the other side of Mars. Speaking of the moon though, it is also a great time to look for what's known as the golden handle on the moon. Now the best time to see this golden handle is around about 4 to 5 days before the full moon. So the next full moon is October 24th, so probably around about this weekend. If you've got a telescope or small binoculars, break those out and check out if you can see it right on what we call the terminator of the moon. So the terminator on the moon is the edge of where the sun's light reaches. And basically if you think about at sunset on Earth, shadows are so much more elongated at sunset and sunrise, the edge of where the sun's light is reaching on Earth. So you get the same thing happening on the moon. You get these really elongated shadows, and so that shows up a lot of detail on the moon. It throws a lot of things into really sharp relief. So these beautiful ridge of mountains, the edge of probably a crater, long gone times millions of years ago, you can see really, really well when the terminator just cuts across them, and it shows them in such beautiful detail. So it's a great, great, great time to spot this feature on the moon. So for those of you who don't have binoculars or telescopes though, there is another thing that I'd like you guys to look out for this month. So the constellation of Cygnus will be right above your head just after it's gone dark. So it might not be one that people are familiar with, but it's supposed to look like a swan or a cross in the sky, so it's pretty easy to find. And then once you have found it, the cool thing is that the neck of the swan or the long bit of the cross traces the path of the Milky Way in the sky. So once you've found Cygnus, you know where to look to see the Milky Way. So if you can get somewhere really, really dark this weekend, then you should be able to see that beautiful white strip of light of the Milky Way running across the sky. Then I've got something for all you early birds and for you night owls. So I've got 2 meteor showers coming up, the Orionids and the Taurids. For all you early birds, you want to try and catch the Orionids meteor shower. This is going to be like pre-dawn on the 21st of October. There's probably only going to be about like 10 to 20 an hour, but if you are, say, driving or you're going to be up anyway, then perhaps you might see a couple coming always away from the constellation of Orion. For all of you night owls, perhaps working night shifts, you've got the Taurids meteor shower. Now that's going to peak around the 5th and 6th of December, which is great in the UK for like bonfire night if you're up anyway and have been watching the fireworks. Keep on looking up at the sky and you might even get lucky and see some meteors as well. These ones are only going to be about like sort of 5 to 10 an hour, so not many, so you really do have to keep your eyes peeled. But again, they'll be coming from the constellation of Taurus, and so once you find Taurus, you look away from there. And now, back to Earth. What has been happening in space news this month? A lot has been happening in space news this month. Oh my gosh, we got so much to get through. Ooh. Okay, so let's start with the big headline from last week, which was the Soyuz rocket launch failure. So people might have seen this on the main news. The Soyuz spacecraft carrying an astronaut and a cosmonaut to the International Space Station had a rocket boost failure mid-launch. So the Soyuz is a Russian rocket and spacecraft that launches astronauts and cosmonauts to the International Space Station. It's currently the only thing we have to service the space station. We used to have the space shuttle, the USA's, NASA's space shuttle, but that was retired about a decade ago. The Soyuz dates back from the 1970s, so it's a little bit old, but it's very reliable tech. It's never had an issue before. It had a minor one in the 70s, but otherwise has like perfect record of launches. So it was weird that there was an issue. Last Thursday though, October 11th, there was a planned launch to get US NASA astronaut Nick Hague and Russian cosmonaut Alexei Ovchinin up to the International Space Station, But unfortunately, mid-launch, there was a rocket booster failure. What that means is that the Soyuz spacecraft didn't get enough boost in order for it to make it to the International Space Station, so they had to abort mid-flight and enter something that's called ballistic descent mode, which as far as I can tell just means falling back to Earth.
This isn't flying, this is falling with style.
And for people who were following on live, it was pretty scary for a while. NASA TV just cut to the control room. There wasn't any updates, except for the fact that when we heard that the spacecraft had actually been seen to launch its parachutes, and also that the crew were then down safe on the ground. It then took rescue crews about an hour to 90 minutes to actually reach the crew, but they were in radio contact the whole time. So it was a relief to know that both the astronaut and the cosmonaut were safe. The Soyuz has now been grounded though, while an investigation takes place as to why this happened and whether the Soyuz can even be launched in the future. Is it reliable? Can we still use this thing? And obviously there are still 3 astronauts on the International Space Station still. Now, they were launched on the Soyuz. The good thing about the Soyuz is that you go up in one spacecraft and you come down in the exact same spacecraft. You basically dock it on the International Space Station and it stays there until you're ready to come home. So they're not exactly trapped there. The issue is whether we can get enough food and supplies to them. I think they have food and supplies now for 6 months, but they were due to come back in December. Now that all relies on whether the actual investigation into what happened last week is finished by then. Perhaps they won't allow them to come down from the space station until they understand the failure, even though the failure was in the rocket booster, not necessarily the actual spacecraft that carries the astronauts. If those astronauts come back from the International Space Station, the International Space Station could be empty for the first time since November 2000. So for 18 years we've had people orbiting the Earth constantly on the ISS, and yet we might now not have anybody. Now the US is also working on its own launch capabilities to the ISS, but instead of obviously NASA-led projects like the space shuttle that we were used to, these are all going to be commercial projects. So you've got SpaceX's Dragon, that was due for crewed test flights sort of early next year. They said that they might be able to pull that forward to the end of this year. Then you've also got Boeing's Starliner. Again, that wasn't due for crewed test until middle to end to next year, sort of August time, but perhaps they might be able to pull that forward. So a very uncertain future for the ISS at the minute, and I really hope that I have better news for you next month. The other bad news this month is that Hubble Space Telescope has gone into safe mode. So safe mode basically means that it's not taking any observations at the minute. It's just sat there biding its time while the team at NASA and at ESA on the ground figure out what is wrong with it. The issue was with one of its gyroscopes. So a lot of people might be familiar with gyroscopes because a lot of people had them as toys as kids. You would spin them and then it would be really, really difficult to knock them over because they're very, very stable when they're spinning. Even against things like gravity, you can spin them on their side as well and they'll stay in that very stable spinning state. And gyroscopes are basically used in a lot of things. You've got one in your mobile phone so you can tell, what angle that you're tilting it at. They're in a lot of navigation devices, and a lot of space telescopes have them. The reason that space telescopes have them is because once you're in the vacuum of space, where there's no real up, down, left, right, north, south, east, west, you need to be able to tell what direction you're pointing in. So a gyroscope allows you to be extremely stable and also allow you to keep very stable pointings, because the Hubble Space Telescope stares at patches of the sky for hours at a time. So it needs to be able to stay staring at a single patch of sky whilst also orbiting around the Earth as well. So it's crucial that these gyroscopes work, otherwise it would be useless for observations. So the Hubble Space Telescope has 6 gyroscopes. Now they were replaced back in 2009. It only needs 3 to function, but 2 have already failed, and the one that failed last week has been acting up for about a year and showing the same kind of signs as the 2 that have already failed, so it was kind of expected. The other 3 are what are called enhanced gyroscopes. So they were expected to live a lot longer anyway. They were sort of a higher tech gyroscope. One of those though has been a little bit problematic for a while, but the other 2 are working fine. So the folks at Space Telescope Science Institute in Baltimore that look after the day-to-day running of Hubble, they've put the telescope into safe mode for now while they try and figure out what they're going to do. So they could try and get this problematic enhanced gyroscope back online if they can. That's plan A. Plan B is that actually Hubble can run in a 2 gyroscope mode if it needs to. So fingers crossed because it's not actually the only space telescope that's had some issues this week. So the Chandra Space Telescope, which is in X-rays as well, that also had a gyroscope problem and has been put into safe mode while they try and figure out what's wrong with that. The Kepler spacecraft, that's also had a glitch, and it's making me very nervous. But fingers crossed, everyone send good vibes up to Hubble and Chandra and Kepler and hope that they make it through these glitches. Okay, so we've talked a lot about our own moon this week, but what about exomoons? So this was big news in the astronomy community over the past couple of weeks. So a paper came out from Tichy and Kipping saying they may have found the first exomoon. So we have exoplanets. Those are planets that are orbiting different stars in our own galaxy, in our own Milky Way. And we've seen star systems before. We've seen stars with 3, 4, 5, 6, 7 planets going around them, just like our own solar system with 8. But this is the first time that we've discovered a moon around one of those planets. So it's been found around a planet called Kepler 1625b, and so the moon has been dubbed Kepler 1625b I. And so the idea of exomoons had been hypothesized before. People have been saying they should exist. Why shouldn't they exist? We have moons in our own solar system. Maybe we can observe them in various different ways. Maybe we can even take a direct image of them, like one of the first exoplanets was discovered with direct imaging. But also this idea of transits to detect these things has also been raised before. So a lot of exoplanets are discovered by transit. So you have a star that's just shining towards Earth, and then you have a planet that passes in front of it. You will get a dip in the brightness of the star, and you will see that in a nice little plot where brightness of the star, or dip when the planet goes in front, and then brightness of the star carries on. And people have said if the planet also has a moon, possibly trailing behind it, then you would get like a double dip. You would get a large dip for the planet and then a smaller one for the moon. And so this is what the researchers in this paper basically went away hunting for. Now they'd seen some evidence for it in the Kepler data, which is the main telescope that stares at all of these stars, checking their brightnesses, but the data wasn't as precise as they needed it to be in order to detect this. So then they got follow-up observations with the Hubble Space Telescope, #pray for Hubble, and that allowed them to actually get a lot more precise data and see what they thought was this sort of double dip transit. And then they've said, okay, well, what models can we fit to the data that we have, and do any of those models suggest that there is a moon? And yes, the best model that the team could find was one that had an exomoon in it as well as an exoplanet. And so what they found is that the planet, Kepler 1625b, is about a Jupiter-sized planet, and going around it, the exomoon, Kepler 1625bi, is about the size of Neptune. So a lot of the exoplanets that we found are what are called hot Jupiters or hot Neptunes. Now those are planets that are, yes, the size of Jupiter, but they're orbiting around their star at sort of the distance of Mercury or Venus, so they're incredibly hot. So just because we haven't seen it in our own solar system doesn't mean that this might not be a common thing. What they concluded was basically that it would be really worthwhile in following up more Kepler targets like this, and perhaps you might be able to find even more exomoons. So, sticking with the theme of moons, because that just seems to be the theme of this entire video, is the moon, exomoons, and now moons. So again, this was a paper that came out in the past week. This one's by Kohlmeyer and Raymond. Basically the question they're asking is it possible for a moon to also have a moon? So planets go around stars, moons go around planets. What goes around a moon? So they refer to them as submoons in the paper, but since it came out there has been endless discussion on the internet about what we should actually call them. So yes, submoons, moons, moonlets, metamoons, moonito, and moons, which is just moon with an extra O added, which I love because, you can then go, okay, so a moon goes around a moon, and then a moon goes around a moon. So they were investigating whether it would even be possible for these kind of things to form. Would they be gravitationally stable in these kind of systems? So back in 2008, we found out that Saturn's moon, Rhea, actually also has a ring system like Saturn. So that suggests the material that you would need to form a moon around a moon is actually there, or could be there, after the formation of the planet-moon system. So basically the authors of the paper wanted to run some simulations to test whether this was even possible, especially for planets in our own solar system. Do they lie in the parameter space that would be gravitationally stable? Because if you think about our own Earth-Moon system, the moon causes tides on the Earth just from its own gravitational pull, and that causes the water on the Earth to bulge and then have tide come in and tide come out. out. If you had an extra object in that system that was also going around the moon, you would get ridiculously high tides when the moon was in between the Earth and the moon, then you would get lower tides probably when the moon was in between the Earth and the moon. But this paper actually found that our own Earth-Moon system could host a submoon in certain cases, something that would be bigger than about 20 kilometers across, so not exactly massive, more kind of like asteroid-sized, but that it would be stable at a certain distance away from the moon, which is pretty cool. So the paper also found that one of Jupiter's moons, Callisto, and two of Saturn's moons, Titan and Iapetus, could also host these submoons, so perhaps we should go looking for them. Perhaps they are tiny around these moons. So if the paper's found that the moon could host one of these things, why doesn't it? And so they argue in the paper that actually, because our moon and Jupiter and Saturn's moons don't host these submoons, or at least we haven't found them, that actually gives us clues to how they were formed. So our best theory for how the moon was formed is what's called the giant impact hypothesis. So this is the idea that another planet collided with the very early Earth just after its formation, liquefied the colliding planet and basically half of the Earth, threw out huge amounts of material into space, which eventually came together and formed the moon. It's possible, though, that one of these moons could capture an asteroid, and then that would be how it would gain a moon. So we think that Mars's moons are two captured asteroids, so there's nothing stopping, our own moon doing the same. Obviously, if they're moving at quite large speeds, though, past the moon, it won't have as much of a gravitational influence on it. Most of the time, asteroids just smash into the moon, which is why it's so cratered. So perhaps it's just not had chance yet, the perfect conditions in order to capture an asteroid so it can have a little moon. But once we figured out moons and possibly even discovered one, the next logical step is there moons? So that's it for this month. Remember, send good thoughts up to Hubble, Chandra and Kepler. I will see you next month for more Sky News, but until then, Dr. Becky, over and out.